Welcome to our final lab video. Here we have part A, the constant current source. So we have the voltage going in through the potentiometer, and that will impact, as you can see in the circuit diagram up here. As we change the potentiometer's resistance value and it's connected to ground, it acts as a voltage divider. So the input to the op amp is changing, which causes a different constant current that goes through the PNP transistor, as we examined in class, because this is a constant current source.
Alright, so I'm gonna show you the IV curve of our voltage control current source. So here we have the voltage of the emitter as a function of the input voltage, and we see that the current at the emitter linearly decreases as a function of the gain. With the slope is given by here, as we can see, 10 power minus 3, which is equal to 1 over Re, as the resistor at the emitter was 1 kilo-ohms. So this is the curve we expected. It's our Schmidt trigger circuit here with a ref and a R1 and a ratio that's around 3.5, sorry. And if we empty in and just in the op amp, and if we operate him, we get that waveforms. In yellow we have the in, so it's an input triangular wave with an amplitude of 2 and an offset of 2, and we can see that the output is a squared wave, the one expected from a Schmidt trigger circuit. We see that it goes up, the output wave goes to the V plus wave when C2 goes under almost 0.75, and it goes down when the input amplitude is 2.6, which is close to the 2.3 expected. So, and this is useful because we have two thresholds, 0.75 and 2.3.
Hello. Here we have our voltage controlled oscillator circuit, the final one from the overall lab. We have the voltage controlled oscillator source, the constant current source, which is impacted by the potentiometer. That goes into two diodes into a system of transistors. Also goes into a capacitor, and at the end there's a Schmidt trigger, which is where our output comes from. So changing the current source will impact the frequency that the Schmidt trigger oscillates, which you can see here. In yellow is the voltage across the capacitor as a function of time, and you can see as the capacitor is charging and discharging, the output of the Schmidt trigger oscillates from high to low, where high is V plus rail that we determined from part B, and the low is V minus rail from part B as well.